Let us now answer these two questions. SN1 reaction is favored by polar protic solvents and SN2 reaction is favored by polar aprotic solvents. Why? What is the reason behind it? Let us begin to answer these questions drawing out the first step of the SN1 reaction. Here is the first step of the SN1 reaction where you can see that this is our reactant and this is our product and this is the transition state. Remember, SN1 reaction takes place in two steps, and the first step is the formation of the carbocation, and this is the rate determining step, right? The alkyl halide, which is the only reactant that is present in this rate determining step, is a neutral molecule which has very small dipole moment. But as the reaction proceeds, when it goes to the transition state, the partial charges on the atoms is going to considerably increase, right? Which means this carbon is going to be more positive and this halogen is going to be more negative because the bond right here is going to break. The bond between the carbon and halogen is going to break. Now, since the partial charges of the transition state is more than the partial charges of the reactant, when you increase the polarity of the solvent, it is going to stabilize the transition state more than the reactant. So let's say that you're going to have a polar protic solvent. Okay, let's take water as an example. We know that there is a partial negative charge on the oxygen and a partial positive charge on the hydrogens. Because you have a polar molecule here, this polar molecule with its partial charges is going to stabilize the charged transition state of the reaction. And similarly, it is going to also solvate both the carbocation and as well as the halide ion that is liberated. So on the whole, a polar protic solvent would favor the formation of the SN1 reaction. Let's see what's going to happen in the case of SN2 reaction. SN2 reaction is a one-step mechanism where this nucleophile comes in and attacks this carbon in a site that's opposite to that of the leaving group, and the leaving group leaves. And this is the step that's going to determine the rate of the reaction. Now, let's say that we are going to use a polar protic solvent. If you use a polar protic solvent such as water or alcohol, it is going to stabilize the negatively charged species, wherein we know that this is a strong base, right? This strong base will try to form a bond with this hydrogen, thereby getting it converted into a weak nucleophile. This nucleophile, which was once a strong nucleophile, after it abstracts this hydrogen from the water molecule, it is now going to get converted into a weak nucleophile, right? But remember, for an SN2 reaction to happen, you need to have a strong nucleophile. Now that is converted into a weak nucleophile, the SN2 reaction is not going to be favored. And another important thing to note down here is we might be thinking that the transition state is also negatively charged, right? But this negative charge is distributed between two atoms, oxygen and Br, and therefore the interaction between the solvent and the transition state is not as strong as that compared to that of the nucleophile. So the polar protic solvent is only going to stabilize or solvate the hydroxide ion, but it's not going to solvate the transition state, which means it will not proceed towards the formation of products. Now let's go on to the polar aprotic solvent. What will happen if I'm going to use a polar aprotic solvent such as DMSO or DMF? If you use DMSO or DMF, they are going to solvate only the cations, leaving behind the nucleophile. So if the nucleophiles are left behind, then it is available for the nucleophilic attack on the alkyl halide. So here, the hydroxide ion equivalent is going to be either NaOH or KOH. Let's imagine that you have Na plus in front of it, right? So when you use DMSO or DMF, what's going to happen is this DMSO is going to solvate the Na plus, which means you will have Na plus in the center, and all of these DMSO molecules or DMF molecules are going to surround this cation, right? Thereby making sure that the OH minus is readily available for the nucleophilic attack, and therefore the SN2 reaction is favored. So on the whole, SN1 reaction is favored by polar protic solvent, and SN2 reaction is favored by polar aprotic solvent. And very simple thing, So in the SN1 reaction, the carbocation and the halide ion is solvated by the polar protic solvent. But in an SN2 reaction, the cations are solvated by polar aprotic solvents.